Hi guys, so today we're going to begin a new unit called additional functions. So we're basically going to learn how to graph a bunch of different functions. We're not going to focus only on just one, like the last unit we worked only on quadratics. Now we're looking at several different functions. So the first one we're going to look at in this unit is absolute value functions, which we had talked about earlier this year. An absolute value function is always going to take on the shape of the letter V. It's going to look like this. It's going to come to a point. So unlike the quadratic, which is a parabola, which is a U shape, this is a V shape. And this point is still called the vertex. And we graph them not using any like table of values or anything that we use for quadratics. Instead, we use translations or shifts of the parent function. So I'll explain what that means. In the first slide, you have the parent function, which is y equals absolute value of x. What this looks like is the vertex is on the origin, and since there's like an invisible 1 here, the slope is 1, so you go up 1 over 1, up 1 over 1, because it's kind of like a linear function, except it's like the bottom of the linear function has been flipped up because absolute value can only be positive. So it's like you've taken this part of the line and flipped it up. So what it ends up doing is going this way with a slope of 1 in this direction. So the way you graph it is the vertex of y equals absolute value of x is at the origin, and each side of the V has a slope of 1. And then you just connect, and you're done. And you label y equals absolute value of x. It's that simple. Now, a translation means to take a graph, any graph, not just these, but all graphs, and to move them to slide them to the left, right, up, or down. A slide is also called a shift. So if you took the same exact graph of the parent function and slid it left, right, up, and down, you could graph other versions of it. So if you take a look at example 2, if you have y equals absolute value of x plus 3, when they add a number on the outside of the absolute value, what that's telling you is that they're shifting it or translating it up that number of units. This is telling you to translate the graph up 3 units. So instead of starting at the origin, instead, you're going to count up 3 from the origin. So you're going to go up 1, 2, 3. That will be your vertex. And since the slope is still 1, your slope in both directions of the absolute value function will be up 1 over 1, up 1 over 1. And in both directions, because it's absolute value. And connect and label y equals absolute value of x plus 3. Okay, so similarly, you'll have in the next example, if it's subtracting 5, this is telling you to shift or translate, since it's minus, down 5 units. So you're going to take the vertex, which of the parent function is at the origin, but you're going to count down 5. So I'm going to count down 1, 2, 3, 4, 5 to there. And then since, again, I'm keeping the slope at 1 for now, up 1, right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. And connect. Did I do that right? No, I did that a little bit wrong here. It should be here, here, and here. And connect and label y equals absolute value of x minus 5. All right, so moving on to the next type of example. Sometimes you'll see a number being added or subtracted inside of the absolute value. If the number is being added or subtracted inside the absolute value, this is shifting it or translating it to the left and right. But it's opposite world in the absolute value bars. So if it says plus 4, like you would normally expect it to go right 4 units, it's not going right. It's actually going left 4 units. So from the parent function, from the origin, you're going to count from here at the origin, you're going to count left 4 units. So you're going to go 1, 2, 3, 4. That's where your vertex is. And I'm keeping the slope right now at 1, so I go up 1, right 1, up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. And there's your absolute value function. Y equals absolute value of x plus 4. And then another example of this would be y equals absolute value of x minus 3. So here, the 3 is being subtracted in the absolute value bars, which tells me it's a left and right translation, but it's going the opposite of what I would expect. So normally I would think minus 3 would go left 3, but it's not. This is going to shift right 3 units. So I'm going to go from the vertex, from the origin, I'm going to go 1, 2, 3 to the right. That's my vertex. Slope is still 1. I go up 1, right 1, up 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. Connect, label. Okay, so just as a summary of everything that we just did, down here, if you have translations of y equals absolute value of x. So remember, at y equals absolute value of x is your parent function. Parent means like the most basic version of it. If you have a number adding onto the outside, like h plus h or minus h, it's going to translate up and down. This is up h units. This is down h units. And if you have a number adding or subtracting inside of the absolute value, it's taking you left and right. If it's plus k, it's actually going left k units. And if it's minus k, it's going right k units. Okay, so I'm going to have you just like practice a couple basic problems like this tonight, and then we'll do a little bit more for after the exam for Thursday. All right, thanks.